Okay, so today we're talking about chemical reactions and being able to talk about whether or not they release energy or take energy in and what exactly a chemical reaction is. So a chemical reaction is just another name for chemical change. Obviously, if a chemical reaction takes place, that means you have new properties after the reaction. And it's very important to understand that no new atoms are made during a chemical reaction. They're just rearranged. And that's the law of conservation of mass. You can't create or destroy atoms. You can only move them around. And that means new compounds can be made. And in order to do that, old bonds have to be broken and new bonds have to form. So there's two parts to a reaction. There's the reactants. That's the stuff you start with. And there's the products. That's the stuff you make. And then there's indications that a chemical reaction has taken place. First of all, there's please. Please stands for precipitate formation. Okay, so when you make a precipitate, a solid falls out of a liquid, then you know a chemical reaction has taken place. Excuse. So we have please excuse. Excuse is an energy change. And an energy change, that just means that you've got one type of energy to begin with and it changes into something else. So you've got chemical energy stored in the bonds of the chemical compounds, and those can be turned into heat, sound, light, or electricity, lots of different things. My coughs. Cough stands for color change. So you get an actual new color, like the solution was clear to begin with and then it turns yellow. We're not talking about it being a lighter tint. So if you have a dark blue and it goes to a lighter blue, it's probably just because you mixed the dark blue substance with a clear blue substance and it got lighter in color because there's clear in with the dark blue. So we're not talking about diluting or making it lighter in color like when you have Kool-Aid and add water to it. We're talking about an actual new color forming. So you started off with blue and all of a sudden you have green, or you start off with pink and all of a sudden you have purple, an actual color change. Sneezes, smell or odor change. Okay, so if you have some kind of smell being given off or an odor being given off, typically that means a gas was formed as well, and that's what's causing the odor. And the last one is burps. We've got bubbles in our liquid. This means that there's gas forming. So our little memory tool, please excuse my cough, sneezes, and burps, stands for precipitate, energy change, color change, smell change, or bubbles, meaning gas formation. When you start a reaction, it always takes a little bit of energy, and that energy goes into breaking the bonds in the reactants. You can use different forms of energy for this to happen: heat, electricity, light. Sometimes it just takes another chemical catalyst, that kind of thing, to get things going. But it's going to take something to kind of get a reaction going. Once a reaction starts, then it's an idea, are we forming bonds, breaking bonds, what's happening? When you form bonds, release energy to some other kind of form, like heat, sound, light, or electricity. Energy is always conserved, just like mass is. The law of conservation of energy, same thing as mass. You can't create or destroy energy, you can only transform it into a different form. Bonds are obviously chemical energy, it's a stored form of energy. And in reactions, you have an energy change, meaning you go from one type of energy into something new. Okay, so we've got two types of reactions. We have exothermic reactions, and that's when if the bonds take less energy than making them, it releases energy as usually heat or sometimes as light or something else. Exo means outside, and therm means heat. So what does this mean? In exothermic reactions, our energy is released to the surroundings, to the outside. So things get hot, or they give off light, or they release electricity. All of those things can be seen in the surroundings. Okay, typically when we talk about exothermic, we talk a lot about things getting hot and not as much about these two. But all three of these are definitely indications of exothermic reactions. Okay, so in this exothermic reactions, in this graph, we have on the y-axis the chemical energy, and then on the x-axis our reactants yielding to our products. And again, this is for exothermic. So in exothermic reactions, we have energy being released to the surroundings, which means that it takes less energy to break those bonds in the reactants than it does to form the new bonds in the products. And so since there's more energy in our reactants than our products, that means the energy had to go somewhere. And it actually went to the surroundings. So that energy is released, and it's released again as either heat, light, or electricity. Typically we talk about this as heat and things getting hot, but it can be any kind of energy release, any kind of energy change from those bonds that are chemical energy, stored energy into some different type of energy that is released to the surroundings. So remember, exo means outside and therm means heat. So we're talking about heat going to the outside, so things feel hot. Okay, in endothermic reactions. Endothermic, meaning it takes more energy to break the bonds than making them. And so it actually has to absorb that energy from the surroundings. So endo means inside. Therm again means heat. So in endothermic reactions, they're absorbing that heat energy from the surroundings to actually break the bonds. And for that to happen, it feels like it gets cold. It requires heat or energy for this to happen, or the chemical reaction will actually stop proceeding to go forward, because it needs energy from the surroundings of some kind in order for this to occur. All right, so same kind of graph we've got here, our chemical energy on the y-axis, we got our reactants and products on the x-axis. What exactly happens? Well, we've got our reactants to start with, and they have less energy in the bonds than our products do. So now we've got a change in energy going up, meaning it had to take energy from the environment, absorb energy from the environment in order to break those bonds to form the new compounds. So this change in energy is a positive change, which means that our heat energy is absorbed by the chemical reaction. And because it's absorbed, it feels cold, because it's basically sucking the heat out of your hands when you feel it through the test tube or whatever. Okay, so this is how cold packs work. Not the ones that you take out of the freezer, but an actual, like a first aid kit cold pack where you have to activate it, you break it or whatever, and all of a sudden it gets really cold. So it started off as room temperature and then all of a sudden it gets cold. That's what's happening, okay? Is it's actually, when it breaks those bonds, it has to take energy from the surroundings, and when it takes that energy from the surroundings to make the new compounds, it feels cold because it's absorbing that heat into those bonds, those new bonds that are formed.